Okay? Now, there are two things that you need to know how to do, one more than the other. Is that you can move between exponential and logarithmic notation, because we know the relationship between the two. So the hard one is going from an exponential to a log. Don't do that very often, maybe about 2% of the time you go from exponentials to log. 98% of the time you go from logarithms to exponentials, because that's how you solve equations. In other words, you undo the logarithm in order to be able to solve the equation. So if I know the definition for the logarithm or the exponential, if I say y equals log base a of x.
We can't see what you're writing.
Oh, I can't see what I'm writing either. Okay. I haven't written anything really yet. If y equals log base a of x, we know that a to the y equals x. That's by definition. You reverse x and y. But it also tells you how to go from a logarithm to an exponential function. Is that the base raised to the exponent power is equal to the argument. Or a to the y is equal to x. Now, if I know that a to y is equal to x, well, what do I know? This is a domain value, and this is a range value. So this guy's domain, this guy's range. The logarithm picks up range values and returns it to domain. Picks up range values and returns it to domain. Picks up range values and returns it to domain. So anytime I'm going from exponential to logarithmic notation like this guy is, and unfortunately I have to kind of think this way, I have three things to fill in. I know I have the log, I have the base of the logarithm, I have the thing I'm taking the logarithm of, and I have the result. The good news is the base is the base is the base is the base, and that guy's the base. So he has a base of 2. Then I have a 50-50 chance of getting the x and the 8 right, because I only have 2 more spaces to fill. But remember what the logarithm does. It takes the range value and returns it to the domain. So it's going to pick up the 8 and return it to x. And by the way, I've just solved an equation if I could calculate out what log base 2 is. I have 2 logs on my calculator. I have log base 10 and log base e, so natural log and regular log. But it makes it harder. It's harder for me to do this than it is to convert from logarithmic to exponential. So if I had y and a minus 1 is equal to 4, I have the log, I have the base, I have what I'm taking the logarithm of, I have the result. So if I look at this guy, there's the base, and the base is y. The logarithm brings the range value, which is 4, back to the domain value, which is negative 1. If I have log to the b, or a to the b is equal to c, again, log, base, what I'm taking the logarithm of, end result. The base is the base is the base is the base, so that's the easy part. Then I remembered that the logarithm brings the range and returns it to the domain. Flips x and y. Now that's, for me, is harder to do. However, to go from logarithmic to exponential notation, I just kind of think about winding it out, because here's the base, and it picks up a range value, takes it back to the domain value, so this is b to the y, and then it's equal to 5. B to the y equals 5. Just kind of go in a circle. To me, it would be a to the negative 2 is equal to, because I'm coming back through the equal sign, 7. B to the a is equal to d. Or b, yeah, that's an a. It's equal to d. Round in a circle, which is what the inverse does. Takes you round and round and round in a circle. This you need to be able to do in your sleep, because you do it so much. This one, this guy, I have to think about, because I don't use it near as much. But this one you're going to use really frequently, because that's how you solve logarithmic equations. You turn them into exponentials, for which we have rules.